Welcome to Coffee and Content, the Mathematics Edition. Today we're going to be talking about integration versus isolation. Over the years, I've worked with students who I'll teach them a concept through hands-on activities, we build deep understandings, and then a week or a month or even a year later, we come back to that idea and try to connect it, and they don't have any clue about what I'm talking about. And over the years, I've asked myself, well, why does that happen? Why can't students connect back to what they've already learned? And I discovered it's because of the way that I was teaching. So I used to teach Learner Outcome 1, Learner Outcome 2, 3, 4, and so on. And I would follow the program of studies and I'd teach everything in isolation. So I decided to do a little bit of an experiment and I would try to connect two outcomes together. So I choose two outcomes that I felt made a nice connection, that I was very purposeful in selecting them. And I found that when I taught those two outcomes together, it was like taking a ball of yarn and throwing it to the other outcome. And I have that little string there connecting them. And it's like building the dendrites in your head, making those connections across the brain. And when I had those connections between two outcomes, it became much more difficult for students to lose one or the other because it had that string holding them together. So after a while, I started to ask myself, well, if having a connection between two outcomes made that connection stronger, what would it be like if I made a connection between multiple outcomes? So I'd connect to another outcome and then I'd connect to a third one and a fourth one, wherever it made sense. And then I'd get this mess, a really messy web of connections. Well, when you've got a really messy web of connections, it's really hard to untangle that. So I've given students that solid connection across so many different outcomes that learning new outcomes or ideas or making connections or seeing patterns in relationships just became so much more in-depth, so much more powerful because of all the connections that we already had. So what does that look like? So I've pulled up the Grade 4 Long Range Planning document here, just a sample of it. You can find this on the Chinook's Edge new curriculum website for mathematics. And we'll take a look at some possibilities for October. But before we do that, let's kind of walk through what this format looks like for this particular document. So it starts with the learner outcome. And then within each learner outcome, we've listed out each of the understandings, not the skills and procedures, not the knowledge, but the big picture understandings we want students to develop through this process. And when I take a look at it, I will see some cells in October that are white. And that's because those maybe you need to wait until later on. They've made some other connections to some of the other outcomes. We're not going to dig too deeply into it if we touch them at all at that time of year. Doesn't mean you can't. It's just a suggested timeline. You don't have to follow it. Then the light colored ones are the ones where you're just going to start to dig into them, play with them a little bit, very concretely in math, no abstract or very little abstract, maybe a little bit of formative assessment, but we're probably not going to summatively assess it. Then you'll see the darker shaded pieces, and those are the ones where you're really going to dig in deep. You're going to do more abstract. You're going to make more connections to other outcomes, and you're probably going to be doing some summative assessments as well as some formative assessments. Some of the cells you'll also notice have restrictions in them. So it might just say, well, you're only going to work up to 100 or 1,000 or up to 12 multiplied by 12, just to try to limit the scope of the numbers, because sometimes the outcome, say you're working to 100,000. Well, you're not going to start that at the beginning of the year. So what's the limits you can put on there so that your students can all reach it regardless if they're working at grade level, below grade level, or above grade level. But then you can use those limits and tweak them to help support students who might need some personalization to push them further or start lower. This timeline is a suggested timeline. You don't have to follow it exactly as it is. You can use it as you wish. And as I go through it and I'm planning my lessons, like, oh, well, actually this connects really well to this outcome. It's white on there, but that's okay because I know that this is a fluid document. So I went through for October for grade 4 and I chose 5 outcomes. that I would try to thoughtfully and deliberately connect together throughout a variety of experiences. They are number learner outcome 3. Students explain properties of prime and composite numbers using multiplication and division. You'll notice in italics it says to 12 multiplied by 12, so there's that restriction I put on there. Number learner outcome 4, students multiply and divide natural numbers within 10,000, but of course it makes sense to stick to 12 multiplied by 12. Algebra, students represent and apply equality in many ways, up to 12 multiplied by 12. Measurement, students interpret and express area. And patterns, students interpret and explain arithmetic and geometric sequences. That says to 10,000, but I would still be limiting it to that 12 multiplied by 12. Materials I'm using in these experiences are the 1-inch square tiles that we supplied for all grade 4 to 6 teachers, a blank multiplication table, and I would make that, because I'm using the 1-inch square tiles, I would want it to be 1-inch squares, and mini whiteboards and markers if students are recording anything. I've also created a Google Doc linked here, and then of course this experience can also be found in the long-range planning documents. So what I'd like you to do as I read through this experience number 1, look at those 5 outcomes and ask yourself, which ones do you think I was deliberately addressing within this experience? It's not going to be all 5. It's really hard to do all 5 all in one experience. It's possible, but it's not something I would want to do with a first experience for sure. So which ones do you think I'm focusing on? So experience number 1, take 6 tiles, build a rectangle using them. And if a student builds a 2 multiplied by 3, a 2 by 3 rectangular array, and somebody else builds a 3 by 2, are they the same? How are they connected? What's the area of that? What are the multiplication statements you can make, or multiplication equations? What are the side lengths? Take that 2 by 3 array and put it on that multiplication chart. Do you see the 2 3s? Do you see the 3 2s? Where would the 6 be written? Repeat that for the 3 by 2. What other rectangles can you build using exactly 6 tiles? How do you know if you found them all? What patterns do you see when you look at all of the multiplication statements? Repeat for 12 tiles, and then I can ask the question, if 2 multiplied by something is equal to 60, and that statement's used to describe a rectangular array, what do I know? So go ahead, pause the video. What outcomes do you think I was attempting to deliberately hit? So ones I focused on, there was actually quite a few of them: multiplying and dividing numbers to 12 by 12, representing and applying equality to 12 by 12, interpreting and expressing area, and looking for arithmetic and geometric sequences, in particular arithmetic in this case. Experience number 2, same thing. What outcomes do you think I'm connecting to? On the board, I would write 6 tiles. Is 1, 2, 3, 6, 12 tiles, 1, 2, 3, 4, 6, 12, 15 tiles, 1, 3, 5, 15. What do I think all those numbers represent? What's the connection between 6 tiles and those 4 numbers, the 15 tiles and those 4 numbers? Here's a new word, factors. See if you can figure out what the word factors means when I say this. The factors of 6 are 1, 2, 3, 6. The factors of 12 are 1, 2, 3, 4, 6, 12, and so on. Why do they all have a factor of 3? Why, sorry about the typo there, why is 15 the only one that has a factor of 5? And obviously giving students time to discuss that and bring that back together. So what outcomes do you think I was deliberately connecting to there? So this time I focused on 3 of them: multiplying and dividing to 12 multiplied by 12, representing and applying equality to 12 multiplied by 12, and interpreting and expressing area. Experience 3. This time we'll take 9 tiles, and we're going to build different arrays, rectangular arrays. The number 9 is one of the numbers that has another special name we can give it. It's also called a squared number. See if you can figure out why it's called a square number based on the arrays that you build. Use tiles to determine if 16 is a square number. Are any of the numbers we previously built square numbers? Find all the factors for each number from 2 all the way to 20 and indicate which of those numbers are square numbers. When you're done, consider all the square numbers. Can you find a pattern that would be helpful in predicting the next square number? So which outcomes do you think I was deliberately focusing on there? So the last four, again, multiplication and division, equality, area, and looking for patterns. Experience number 4. So this is a concept sort. So I'd make 2 columns on the board. In column A, I'd put 12, 15, 18. In column B, I'd put 3. And I'd ask the question, where do you think 6 would fit? It'd be column A. Where do you think 5 would fit? And I'd show it'd be column B. And repeat for all of the other numbers except for the number 1. And then I can introduce the language of prime and composite number. So composite relating to the word compose, putting together. And in the Google Doc, there's a link to the definitions of where those 2 words come from. So I would share that with students. And then I'd ask, well, which of these 2 columns represents prime and which one represents composite? So instead of telling students the definitions and telling them which one the columns match, I'd ask them to use the definitions I've explained to figure it out. And then we can have that conversation around, what are your thoughts around the number 1 and 0? Why aren't they prime or composite? So here are the outcomes. So the first 4. This time I'm deliberately bringing in prime and composite numbers, multiplication, division, equality, and area. Less about patterns in this one. I wasn't deliberately focusing on having them identify patterns or create a pattern. Experience number 5. Compare the factors of 6 and 8. What relationships do you see between the factors? So they both have 1 and 2. What about 6 and 9? Well, they both have 3. So here's a new term, common factor. So 1 and 2 are common factors for 6 and 8, and 3 is a common factor between 6 and 9. So knowing that, what are the common factors for 12 and 18? And what's the largest or the greatest common factor for all of those? What are the common factors between 4 and 8? What do you notice? Why do you think that happens? What is another number you think might share all the same factors of 4? Will it also share all the factors of 8? Could you find one that would? Which outcomes do you think I was deliberately focusing on there? So again, outcomes number 1 through 4 is listed here. Some other experiences, I can repeat all of that using relational rods. And the only thing I would have to change is make sure my multiplication table used 1 centimeter square instead of 1 inch squares. I don't have to create brand new experiences. I just repeat the same one so students have another concrete way of looking at it, using a different manipulative, but using the same experience. Grade 5 long-range planning documents. You can also find those on the new curriculum website. So what I'd like you to do is I've picked 6 outcomes here: divisibility of natural numbers, multiplication and division, up to 12 times 12, students interpret numerical and algebraic expressions, relate location to position on a grid, estimate, calculate area using standard units, and relate terms to position within arithmetic sequence. So if you take those same grade 4 experiences, how might you tweak them or add to them in order to hit these outcomes? That would be grade 5. Go ahead and pause the video to think about that. So here are some of the experiences I came up with. I can do the exact same grade 4 experiences with building rectangular arrays, because that's still going to be about divisibility, multiplication and division. I'm giving away some of my outcomes here, but that's okay. I can create a 2x1 array using the tiles, and then I can create a table to represent length and the area of that array. And then I could change that 2x1 to a 2x2, and then I can ask, what's the new area? What's the new length? I can repeat by 2 to 2x3 and 2x4. Do I see a pattern? Can I predict if the length is 5, 10, and so on? So which other outcomes do you think I'm hitting there? For grade 6, long-range planning documents, what experiences could I take from grade 4 and or grade 5 in order to connect to the grade 6 one? So the outcomes are listed on the screen, but it's about prime factorization and exponentiation, standard algorithms for multiplication and division of decimal numbers by natural numbers. Please keep in mind, grade 6, you do not multiply decimal by decimal. It is only a natural number by decimal. Algebra, so expressions and solving algebraic equations. Students explain location and movement in relation to position on the Cartesian plane. Students interpret and express volume, and students investigate functions to enhance understanding of change. So how might you tweak those experiences to hit these outcomes? So again, you can repeat those same experiences from grade 5. You can provide students with a known dimension and the total area, and we can do that first concretely, then we can connect that to an algebraic equation and have them work backwards to find the missing dimension. And I didn't mention this for the grade 5, but I could have them throw it on a coordinate grid. So in grade 6, it'd be Cartesian plane. And if I have it matched up to 1-inch square tiles, if I'm using the 1-inch square tiles, then we can connect back to that on the plane. It's kind of like when they built the multiplication grid, but just switch it to a coordinate grid, and then in grade 6, a Cartesian plane. But in grade 6, I can introduce the language of independent and dependent. The area is dependent on the length. I can look at 1, 3, 2, 3s, 3, 3s. I can use relational rods or Unifix cubes to build a 3x2 array to determine the area. And then I can add a second level to determine volume. So volume can be just slipped in there by building upwards and exploring that idea as well. So for me, there are some outcomes that should always be brewed together. And you'll notice most of these fit within the number strand. When I'm talking equality, that should be always connected to all of my operations. Should be connected to, and it says grade 3, but 3 and up, so 4, 5, and 6, patterns, algebra, fractions. Place value always builds into equality, the operations, patterns, algebra, and fractions again. When you're talking about addition, subtraction, you should always be talking equality, place value, patterns, algebra. I can incorporate in statistics and geometry and time and measurement. For multiplication and division, again, I can do all the same things as I do with addition and subtraction. I should never talk about multiplication, division in isolation. I should always be connecting equality in there and place value, and I can do so many things instead of teaching it as it's each of these as their own learner outcome and never connecting to the other ones. So what I'd like you to do is take the rest of the time you have available now, dig into your curriculum and look for opportunities where you can deliberately and thoughtfully connect outcomes, maybe in ways you hadn't thought about before. Start with just finding 2 outcomes to connect and look for ones that maybe you can use next week. Make it something simple. It doesn't have to be a huge, elaborate opportunity. But when you connect multiple outcomes, then you provide students an opportunity to explore those outcomes with excelling thinking and to demonstrate an excelling understanding of those outcomes. So hopefully you found this helpful. As always, if you have any questions, please feel free to reach out. I look forward to seeing you in the future.